Hello, welcome to the final presentation of Group 2. My name is Erik Lowney. This is my capstone partner, Erik Burgess. This is a two-person capstone. Our project is the Mobile Multimedia Multi-Chat System. And in this presentation, we'll explain to you exactly what that means. Our advisor is Dr. Satya Narayanan, and our client is John Gibson at the Naval Postgraduate School in Monterey. So the Naval Postgraduate School is currently researching rapidly deployable mobile telecommunication infrastructures. That basically means they're developing ways to implement infrastructure in places that don't have a communication system available, such as after a disaster or in remote parts of the world. So they asked us to create a communication system that would allow for location sharing through GPS, through text messaging, and through group image sharing. The difficulty of this project is that it has to be small, compact, easily deployable, and most importantly, it needs to work without needing access to the internet. So our solution to this problem is the MMMC, and it is basically consists of a smartphone application and a small portable server that works on site. And then Erik will talk about more.
All right, so the mobile multimedia multi-chat system is developed for the Android platform. It's based on the Extensible Messaging and Presence Protocol, or XMPP. So our project utilizes multiple open source projects, including called ASMAC Chat, which currently provided one-on-one chat functionality, and then ASMAC service, which provides connection management as well as the ability to send and receive messages. So what we did is we developed a solution by extending the ASMAC Chat service and the ASMAC Chat client to provide multi-user chat, image sharing, as well as location sharing. So the application we developed includes an interface, which is shown here below, and it's actually 3 tab screens that you flip between. It uses a device's built-in camera, and then on the right screen here, it lists pictures that you've taken, as well as pictures that you've received from other people. On the left side, it lists who's in your group, as well as their current location. And then in the middle here, you have the chat room itself. So next we have, this is an overview of how our system works. These top 3 components here run on all the Android devices, and it includes our application and then the ASMAC service, as well as an API. Our server is OpenFire, which is an open source XMPP server. So our application works by, when you want to send a message, our application gives the message to the ASMAC service, which then forwards it to the server, who's responsible for delivering the messages to all members of the group. And best of all, it actually works.
So what did we learn in this project? Well, first of all, of course, we learned Android application development, which is not an easy thing. We learned XML, or Extensible Markup Language, which is basically just a way of formatting and tagging data. It's pretty generic. We also learned XMPP, which is the core of our project. XMPP is a messaging protocol that relies heavily on XML. And then, of course, XML and XMPP is very flexible and extendable by design, and this feature allowed us to implement the location sharing, image, and picture sharing. We learned that robust programming does require a lot of time, effort, code, debugging, etc., etc. And of course, we also learned very strong software design principles. So we'd like to acknowledge the Buddy Cloud developers. They created the Android SMAC API, which is basically a way of running XMPP on handheld devices. I'd like to thank our client, John Gibson, at the Naval Postgraduate School for assigning us this project. Drs. Bune and Lockwood for instilling in us some strong programming foundation. And of course our advisor, Dr. Satya Narayanan, for his guidance and support. And of course, I'd like to thank our friends and family as well. So that concludes this. To see a working demo of our application, you can join us in the poster session in room 110.